Hello everyone. I welcome you to our presentation about Alps Crossing in the in this month of December. We are H42, a student course of the German Meteorological Service, and in the photo you can see us at our future workspace, as it will be our job to brief pilots about the current and the future meteorological conditions. Furthermore, balloon pilots are our customers as well. 12 days ago, we had one of a few days in a year with perfect conditions to cross the Alps with a hot air balloon. As already said, I'm Lars, and together with my fellow student Lennart, sitting next to me, we will inform you about this topic in a short presentation. Thereby, I'd like to start with some basics about flying with a hot air balloon. This includes necessary meteorological conditions for crossing the Alps. And after that, Lennart will analyze the general weather situation of the day we are talking about, the 7th of December this year. Before we start, we want to get more information about you, our listeners. Therefore, we'd like to ask you to put a sign on a map I will show you next and where you come from. We will go first and give furthermore some additional information on our weather. Our campus is located in Langen, a small city next to Frankfurt. And due to much mist and low stratus, we expect just a few minutes of sunshine today, while 4 degrees Celsius will be the maximum temperature of the day. So now it's your turn to comment the whole, or comment where you're coming from. Oh, I see Portugal. And as I read in the chat, somebody from the east coast of the USA, maybe he can't participate in that. Yes, as I see also on this map, some persons of you have slightly better meteorological conditions for sunshine or than we have here. It's really gray here. One of the most important things for ballooning is to monitor the thermal circulation. And herefore, I want to talk a little bit about that. Basically, it mixes upper air levels and lower air levels. So if you have strong upper level winds, you have, with the beginning of the circulation, more gusty winds at the for the surface. So you expect then obviously more gusts. To avoid this, there must be a strong surface inversion to separate the levels. If there's just a small piece of dry adiabatic cooling with height, the circulation can start. Also, as here shown in the picture I bring to you, we have a strong inversion which separates the upper level winds from the surface winds at nighttime, especially when we have this inversion. Or at the daytime, we have mixed layers, so maybe some of the upper level winds will come down to get in form of gusts. So interesting at that point. Excuse me. So, due to the point that most balloon pilots doesn't start or land with gusts about 10 knots, and somebody tells you something like 12 knots, but not more. A small circulation already can lead to stronger surface gusts. So everybody or balloon pilots won't start in thermal circulations or in times of thermal circulations. Therefore, it has to be monitored if you're talking about flying a balloon. And for that point, here are some rules of thumb for the end of the circulation we use here. If you have cold advection in the air, it ends 1 to 0 hours before sunset due to the great temperature gradient between the surface and the air above the surface. In an air mass without any advections, it'd be 1 to 2 hours before sunset. And while there's a warm advection, we'd talk about 2 to 3 hours before sunset due to the small gradient in temperature between surface and the air above. And an interesting point as well, as you probably all know, is the fact that hot air balloons just follow the upper level winds, and so they need to have stronger winds in their height they want to fly. If there's no winds or really, really slow winds, they also don't want to start because they just doesn't move. And obviously, balloon flights mostly have a commercial background, so that they want to let their customers see as far as possible from the sites or from the place they're being. So an inversion in the air without saturation or without clouds would be nice for the best sites they can get. But let's get back to our topic, which is crossing the Alps in a hot air balloon. And therefore, we need to meet some special requirements. The first point is that it has to be during the winter month to get the best thermal conditions. The beginning and the end of the thermal circulation are really close together due to the late sunrise and the early sunset. And as well, maybe there is some snow which inhibits the thermal circulation completely. The second requirement we need to meet is a ridge above Western Europe to get northerly winds against the Alps to get over it. So there's importantly no crossing the Alps from the south to north, because therefore southerly winds would be needed, and southerly winds often goes ahead with trough, or according to trough, and trough is mostly connected with weather phenomena like thunderstorms or showers, and balloon pilots doesn't like thunderstorms or showers due to the rain or downbursts and many other meteorological conditions combined with that. So we need strong upper winds from north, and strong means 40 knots if it's straight ahead from the north on the Alps in 500 hectopascal. And if we have a flatter angle on the Alps in 500 hectopascal, the wind always need to be stronger to have the chance to get over the Alps while it's daytime and not flying in the night. And at that point, I want to hand over to Lennart, who will analyze the situation on the 7th of December this year.
All right. So I want to start with a map of the 500 hectopascal geopotential and temperature. And on that day over Europe, we had in Eastern Europe this ridge that stretches from Finland down to the Black Sea. Then upstream, we had a ridge that goes from Scandinavia down to the Ionian Sea, and then it's followed by again a ridge, a trough over Central Europe, and then a ridge again from the North Sea down to Andalusia. In the ground pressure, we can now see that the ridge in Eastern Europe has facilitated a strong system of high pressure over northern Russia and Scandinavia, which also influences Central Europe, as we have a small pressure gradient in this area. And only when we go further west, we see these three systems of low pressure, which also control our frontal system, with one warm front over the British Isles that then goes down to the Bay of Biscay. And then also a secondary warm front controlled by this low pressure system that then also roughly follows the same path and then is closely followed by a cold front. The fronts you can also see very well in the moisture field in 700 hectopascal, with yellow areas indicating low moisture content in the site and green indicating high moisture content in the site. And there we can also see once again the frontal systems very well, with the area of postfrontal subsidence separating these two fronts. And what we also can already see is that in Central Europe we have, first of all, rather dry air in the middle troposphere, and with the arrows indicating the wind direction. In this level, we can also see that we have northerly to northerly western winds, as we would like with an alpine crossing. And then I also want to show a satellite image with the HRV RGB composite. And there, as that's animated from 8 UTC to 15 UTC on that day. And there we can see that over Eastern Europe, we have lots of low stratus and fog, as we would expect with the high pressure system. Then over Western Germany, we can already see some subsidence before the front moves in, which is controlled by this, in my opinion, beautiful cyclone over the Northern Atlantic. So for crossing the Alps, there is generally a checklist that meteorologists use to analyze whether an Alps crossing is possible or not. And therefore, you look at 3 general areas. The first one is north of the Alps, because that's where we want to start. Then the weather en route on flight level 118 or 18,000 feet above sea level, as that's the general height where the hot air balloons will travel. And then in the end, of course, the weather south of the Alps, where we want to land. So for the weather north of the Alps, as has been explained by Lars before, we first want to check when our thermals are going to begin. Then the visibility and cloud cover, which in this case, due to the northerly winds, we often have an accumulation of clouds at the Alps. And as the balloons are not allowed to go through clouds, they need to have cloud-free areas to ascend. And in the end, we also have to look at the ground wind, where depending on the pilot, the speed limits can range. The middle way, I just try to do the mean speed, which is 8 knots. So to first look at the thermals, I have 2 vertical profiles, which were calculated by our regional model ICAN D2. And here in this one, which which was calculated for south of Munich at 9 UTC, we can still see our ground inversion very clearly present, while with this vertical profile, which is already for 10 UTC, we can already see that our ground inversion has dispersed and we have a dry adiabatic curve. And as such, we can now say that the thermals are supposed to begin around 9 to 10 UTC. Then to take a closer look at the satellite image and the wind speeds that were measured at 8 UTC. There we can see over north of the Alps in Bavaria that we have these fields of fog widespread. However, you can already see that we've got a lot of patches that is free of fog and clouds. So the hot air balloons will have ample of chance to find a spot to launch without going through clouds. The wind speeds indicated with the wind feathers was also very low, with around 2 to 5 knots. And with the numbers representing the gusts measured, we have gusts up to between 6 and 8 knots, which also still is fairly manageable. And already looking at an outlook for when we are trying to land, we got basically no to little clouds over the Po Valley and Veneto, which also means that we probably are going to have good landing conditions. But of course, there goes a bunch of other stuff into it when we want to forecast that. Yeah. So now that we have checked the conditions north of the Alps, we now want to check how the weather is en route. And for that, we want to check whether we have northerly winds, whether we have wind speeds between 40 and 50 knots, because if we go any slower than that, the travel time will be too long. We also want to check temperatures, as the people are flying in basically an open cabin, and they need to know how thick of clothing they need to take with them. And then, of course, with anything that's flying, we have to check whether there's any turbulence en route. Now I have a calculated field from our ICAN 6 model, which shows, first of all, the wind feathers with the wind speed in knots, and the temperature in this colored field, where one color always represents a gradient of 2 degrees Celsius. So as we can see here, as well as north of the Alps, as well en route, and south of the Alps, we have wind speeds in the west between 35 and 45 knots, while in the eastern Alps we have wind speeds from 45 knots to even 55 knots. Of course, northerly winds to northwesterly winds. So the wind is also in great condition for our flight. I forgot the temperatures being around minus 20 to minus 24 degrees, which also is, for these types of flights, very much manageable. And for the turbulence, I've brought you a product which is also calculated from our ICAN 6 model, which shows turbulence in different flight levels. Of course, this model on itself is not sufficient enough for that. We, as meteorologists, have to analyze vertical and horizontal wind shear with the wind feathers on each own to validate this. But on this day, this model fed very well, which is why I'm only going to show you this. So as we are flying in flight level 180, we want to look at this window here. And there we can see that on our flight level, you basically have next to no turbulence calculated by the model. And as such, this won't really be much of a problem to us. Now, at last, now that we have checked off the en route weather, we are going to look what the landing conditions are going to be. There again, we have to check the thermals, as we want to land after the thermals. Then we also, just like the north side, want to check the visibility and cloud cover. As I've already said, the Po Valley is very vulnerable to fog cover. And at last, ground winds again. And here we also have to look whether we already got the Föhn storm going on. As with northerly winds, these can very much occur. And as they are quite extreme, when these occur, there's no chance that a hot air balloon is going to try to land. So like we did with at the start, we are going to check some vertical profiles for ground inversions. From this, I chose Veneto at 14 and 15 UTC. With 14 UTC, we can still clearly see the dry adiabatic profile near the surface level. And in the meanwhile, at 15 UTC, we already see a ground inversion has developed, which means between 14 and 15 UTC, we are going to expect the endothermals. As such as these flights, depending on, of course, where you start and how fast the wind speeds at cruising altitude are, these take around 5 to 6 hours. So as we have already noted before, with thermals starting between 9 and 10 UTC and then now ending between 14 and 15 UTC, there's quite a good window to start and reach the destination within this time frame, completely outside of the thermals. Now to check for wind, and as we are having a forecast, we of course won't have any ground data, so these are also calculated wind speeds with the wind feathers representing the mean wind speeds and the colored areas significant areas of gusts. And as we can see here, in the lowlands, we have basically next to no wind with winds between 1 to 3 knots from various directions, and no significant gusts are to be expected. So we are also clear on that side And of course, with these low wind speeds, there isn't going to be a föhn storm. Yeah. So with that, our checklist is complete. And as we have now demonstrated, conditions should be perfect for alpine crossings. And if you were to have checked Flight Radar 24 on that day, you would have been able to observe a lot of hot air balloons crossing the Alps. Here I've got a screenshot from 9:30 UTC. And as you can see, we got a bunch of hot air balloons already over the Alps. And as such, with them actually flying on that day, our meteorological forecast or analysis has been confirmed by observation. And that means we've done a good job. Also, one thing, which is also why we chose this topic in the first place, we had already done a forecast for this on the Monday of this week, while this day is the Thursday. And the models, at least ICANN and IFS, already match very well with what had been observed on that day. And I think this just once again shows how far we've come with numerical weather prediction, as it basically has already forecast 3 or 4 days advance the exact conditions that were observed on that day. And now I'm going to give it back to Lars.
I'm going to do nearly the end of our presentation at that point. So obviously, as you see, we have already balloons flying over the Alps at that day, and we have videos exactly from that day. A balloon started in Switzerland and going to Italy, or nearly that route Lennart showed you as well. So I have to search for the video where, excuse me, that wasn't the video. This is the video. Where we already can see the setup of the balloon and how they are going to start it. As you can see here, we have no clouds, or nearly no clouds in the sky, so best conditions to start here. And as you see, the balloon just moves up slowly, so we have no or nearly no winds or gusts having or causing a problem while starting. So perfect day from the start here. And I think, of course, you all want to know how it looks like if you are flying across the Alps. And obviously, there's also a little video. Yeah, I want to show it first. At that point, I have to say these are short parts of a video on YouTube. You can see the full video on this channel I've put here. And as you all can see, it's nearly very beautiful to see the Alps from the top, snowy, very well with snow and so on. So if you want to fly with that, it's nearly expensive, I think. You have to take 1,500 to 2,500 euros for one flight, and you have to wait a couple of years due to that point that you have so many many persons who want to do that, and so few days you can do that a year. So you need time and money at that point. And in this, I think we will end our presentation at that point.